Yeah, Ooh. Larson. Bobby.
Yeah.
Physics.
Yo.
AP.
Oh my god, Ronnie.
Yo.
Averaging. Rounding. Scientific. Notation. Significant. Figures. Make sure that number don't get big. 1 trial, 2 trials, 3 trials. Like my data. Like my chopper. Exactly, precisely, accurately. Take those numbers. Add them up. Divide them. Yup. Make those tests. Simplify. Graphable. Side to side. Got 2 numbers. Different size. Multiply. Add, subtract, or divide. I'ma let Melita decide.
So significant figures and rounding. So let's say we have 3 trials, right? We want to add them up. So we have 6, 8, 4, and 0. The amount of significant figures that your answer has is determined by the least amount. So we have 1, 2, 3, 4 of them, and 4. So that means that our final answer should have 3 significant figures. Now this 0 counts as a significant figure because it shows how accurate your measuring was. So let's say you have like a ruler, right? And this is like 1/10 of an inch, right? So you have an inch and here's 1/10 of an inch. That when you measured, you were so sure that your distance was 1/10 of an inch that the 0 like solidifies it. So that's become the 0 counts. So rounding now. Rounding, you either round lower or higher. So since we want 3 significant digits, this one can determine what this number should be. Since it's a 6, that means our 8 should become a 9. And this is because when rounding, if the number after the number you're trying to round is bigger than 5, then you should round up to the next digit. If your number is less than 5, then you should round down. And if your number is 5, then you should round up. So it's really good like that. So that's become 8 becomes 9 because 6 is bigger than 5. So that means your final answer should be 0.49.
Oh my god, Ronnie.
Yo.
Back to me. Averaging. Rounding. Love my data. Like my chocolate. Exactly, precisely, accurately. Got a number. Way too big.
Yeah.
Cut it down. Or Tommy frowns. Move that point until the ones. Take that 10 to the end.
To the end.
Don't deny it. Multiply by the number that you got. Kilowatt, megawatt, gigawatt, watt. Got a number. Way too small.
Yeah.
Repeat the process. I digress.
Now we're focusing on scientific notation. As I said earlier, the n is the number of places, so there's 4 places right here. If you're trying to simplify that number, the decimal point is technically right here. What you're going to do is you're going to move that decimal point until you get to the one right before the ones place. Likewise, this n represents the number of places that you move. So since it started right here and I moved 1, 2, 3 places over, that's going to be 10 to the third, and then I multiply that by the number that I moved it over, and that's my scientific notation. So if you have a number that's too small, you're going to move it over until you get to the ones place, 1 in front. This will give you 8.7. Since you moved it over, n equals 2 times, you're going to multiply that by 10 to the negative second. And that way you'll have your final scientific notation.